Hello everybody, this is Dr. Sergey Sarkisov, and today we will discuss the algebra of fractions. So here goes. If you have a fraction, let's say we're adding 1/2 plus 1 over 4, right? Let's say we're doing that. Well, what do? Well, we're thinking, okay, well, let's see. 1/2, sometimes there are multiple ways I'll teach students. I'll say, look, let's talk about money, right? You have 50 cents. Or 50% of a dollar, right? And then you add 25%. We're used to that, right? 25 cents, so a quarter of a dollar, 1/4. And you get what? 75%. And that's 3/4, right? So that's one way you sometimes look at that. Well, another way, a more kind of formal algebraic way, let's say, mathematical way, would be 1/4 plus 1/2 plus a fourth. We'd say, well, how many fourths is each of those? Because you want to add the same size pieces, I always say. In other words, you want to have how many fourths plus how many fourths, right? So you have actually 1/2 is, you make it times 2, top and bottom, right? And then plus the 1 over 4 there. And then that's exactly 2 over 4, right? 2 over 4 is exactly 1/2, right? So 2/4 plus 1/4, and that's exactly, what's 2 plus 1? It's 3 over 4, the same result. Now, another way to do this is, let's say you have a pizza slice, okay? Well, a pizza slice, here's a circle. And what's half of the pizza? Well, that's half. Let's shade it in like this. Half of the pizza, right? And we're adding it to, let's say, a fourth of the pizza. So we divide this pizza into 4 pieces here, right? Fourths. And we're talking about, well, let's add this piece to the one on the left. But think about it. You're adding a half plus a fourth. Those are different size pieces, right? So how much of the pizza will you actually have? Well, to do this, I would say, let's do this. Let's say instead of 1/2 plus a fourth, we actually get what? We actually get, well, let's divide this into fourths, everything, right? What's a half? It's actually these 2 pieces. It's 2/4, right? That's why it's 2/4, because half is 2/4. You see it visually, right? Plus that other fourth. Let me make sure it's a little neater here. Plus the other fourth. And that's exactly what do we have left, or what do we have added together? The sum is it's going to be the 3/4. It's going to be those 3 pieces. You're only not having that one on the bottom right. So you would have this one here, and this one there, and that's 3/4 of a pizza, right? Right, everyone? That's why I like to show that demonstration with pizza slices, right? That's one idea. And then another idea is, look. We have we can cross multiply, or like I call it the butterfly method, where what we can do is we can say, well, it's a half plus a fourth, right? And this is actually, if you know kind of I'll show you the reason for why this is going to work always, okay? But what we can do is we can say, well, let me do this 1 times 4, right? So 1 times 4, plus let's do 2 times 1, okay? And then all over what's the product of the bottom numbers, let's say 2 times 4. You see, it's like the wings of a butterfly in a way. You go tunt, 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 right? Kind of like that. So that's an idea that why I call it the butterfly method, or cross multiply, right? And then divide by the product of the denominators. So again, remember, fraction is consisting of a numerator on the top and denominator at the bottom, okay? And it's a rational number if it's an integer on the top and an integer at the bottom. Just remember those terminologies. Anyway, so look, what we have is okay, this is 4. 1 times 4 is 4. Plus 2 times 1 is 2. All over 8. Very much a different approach, right, to solving this summation of fractions. And it's going to be 6 over 8, which is actually, let's say, before I do 3 over 4, what if I say, well, this is 2 times 3, right? Let me kind of factorize this a little bit. This is 2 times 4. And we can see the 2's cancel, right? And we have 3 over 4 left. That's another way to see that. It's 3/4, okay? So multiple ways. And let me show you why this bottom one always works, okay? This is very important. Why does this bottom method always work, right? Well, here's why. Let's say I'm asking you, hey, in general, let's look at the algebra of fractions. In other words, what if we have some unknowns? So it doesn't have to be some parameters. Let's say we don't have numbers like 1/2 and a fourth, but what if we have numbers a, anything a, right? Could be any integer, over b. So there's one fraction plus another fraction c over d, right? Imagine anything works. So a would be, on the earlier problem, a is a 1, b is a 2, C is a 1 and D is a 4, right? 1/2 plus a fourth. So let's see, how would we do this? Well, let's make a common denominator. Like we did at the top right here. Look, we talked about, let's have everything fourths, right? And so what we did was we said, hey, let's make this a fourth here. This is already a fourth, and so we have 3/4 together total. So we want to see what pieces are we adding? The same size slices of pizza, in other words, right? So what we can do is we can multiply top and bottom to be fair, right, to the fraction. If you multiply by the same thing, top and bottom, you're basically multiplying by 1, which is not changing anything. So look, what if I do A over B, and I'm going to multiply this by, look, D over D, okay? And what is this one? I'm going to multiply C over D. Let me multiply this, and let me do it on the left. It's okay, it doesn't matter which direction, but look, let's say B over B. Multiply that, B over B, like that, okay? And the reason I'm doing this, let me show you why this trick will work. Because look, this is equal to, well, that's exactly AD, right? A times D is AD, over BD. So we have BDths, right? Like not thirds, not sixths, not fourths, but BDths. BD over BD slice type pizza, right? And BC over BD here, right? That right fraction. And so this is actually equal to, now we can actually add them up, right? Because you have the same, you're dividing by BD, both fractions. So you have the same size slices. You have AD of these, right? And you have BC of these BDs, right? So BC, AD plus BC over BD, okay? This is exactly right here, this right here, okay? Is exactly this right here. All right. And one thing I want to call, why I sometimes call this like the butterfly method or the cross multiplication, is now look, if you do A over B plus C over D, right? Let's do this one more time. Let's just do the cross multiply method or the butterfly method. Look, A times D, AD, plus B times C, BC, all over the bottom product of the denominators, BD. Hey, that's exactly what we have right there, right? And so let's right there. And so now look, let me show you one thing. Let me show you another. Let's do another example, okay? Let's say I'm subtracting fractions this time, okay? Let's say I'm subtracting fractions. Let's say I'm subtracting fractions 1/2 and 1/3. So 1/2 may be minus a 1/3, okay? The difference between 1/2 and 1/3, okay? And to do this one, it's a little trickier than the first one, 1/2 plus a fourth. Okay, so a lot of my students sometimes miss this problem, getting this. Like the 1/2 plus a fourth, a lot of people get 3/4. But 1/2 minus a third, it's a little trickier, seemingly so, but it's the same idea. So look, if we didn't know the formula, this right here, right? If we didn't know it at all, what we can do is we can say, well, look, first let me do the kind of make it the same size as at the bottom. So what can we do? Well, instead of 1/2, you see there's how do I make it the same thing at the bottom? A least common multiple of these two, or you know, the denominator there, we could do a common denominator would be, let's do 6, right? So 2 times 3 and times 3 at the top and bottom, right? And then minus now let's multiply top and bottom here by 2, so 2 times 1 over that 3 there, so 1/3, and then 2 times, let me make that a little neater here. So there's 1/3, and then you do 2 top and bottom by 2, okay? And this is exactly now the reason we did that is because we have 3 over 6, you see 3/6, right? Minus 2 over 6, and now we have the same sixths, right, that we're subtracting. So 3 of them minus 2 of them, and that's exactly 1/6 left, right? That's interesting. 1/2 minus a third is actually 1/6. And one other thing to look into, let's do a visual pizza representation of this. So look, here's a circle, and I'm going to do, how do you get it into 6 slices? Well, you have 3 cuts, right? 1 cut, 2 cuts, 3 cuts, and now you have 6, right? What's a half? Well, it's the left half of the pizza, let's say. There are 3 of those, 3/6, right? And then minus 1/3, what's 1/3? Well, let's see. That's going to be, remember, it used to be this. That's like that, right? That's what 1/3 of the pizza is. But look, if they divided it into 6 pieces, what happened is actually it's 2 right here and right there is 2 over 6, right? And so you have 3 over 6, and then take away 2 of the same size slices, 2 over 6, okay? And you're left with what? Right? You're only left with one slice, right? So you're going to be left with, if you divide this into 6, right? Like those 3 cuts there, you would have this left, okay? And that's exactly 1 over 6. And then finally, let us do the formula. Remember the cross multiply. And then we'll write the formula one more time and we'll finish up. So let's do this. 1/2, the cross multiply or the butterfly method, let's say 1/2 minus a third, right, is equal to, well, it's going to be 1 times the 3, 1 times the 3, minus the 2 times the 1, minus because there's a minus sign, okay? It's like actually what we're doing is we're adding, it's a half plus a negative 1 over 3. Think about it that way. That's why it's a 2 times a negative 1, or minus, right? So let me just erase that, but remember that's why, because if you subtract, you're actually adding a negative number, okay? It's kind of tricky there too. So 1 times a 3 minus a 2 times a 1, right, by the cross multiply, and we have this all over 2 times 3, the product of the denominators. That's going to be 3 minus a 2, right? 2 times 1 is 2, all over 6. That's going to be exactly 1 over 6. And what we actually did was we did the formula, which is, let's put this in a box soon enough. So a over b, okay, plus c over d. We call this the algebra of fractions, okay? That this always will work for any values you put in for this. These are unknowns at the moment, right? These are parameters that we do not know in general, but we put in any numbers, it should always work. So it's going to be AD, right, plus BC all over BD, okay? And make sure you understand this is not the same at all, not the same as A plus C over B plus D, okay? Let me put this formula in a box. It's a very important formula, okay? Very important. Do another box like that and just kind of highlight it, double highlight it, kind of make it look really cool. And let me just show you quickly, last thing, so that we finish the formula there, everything like that. But I want to make sure we understand, look, if I said A over B plus C over D is equal to, which I said it's not equal to, right? It's not equal to A plus C over B plus D, which a lot of students make that mistake, right? You don't want to do that. Let me show you why. Like, what if it was, right? Well, let's say we did 1/2 plus a 4th, right? Like we discussed. Well, that would be actually 1 plus 1 is 2 over 2 plus 4 is a 6, right? We get 2 over 6, which is a third. Are you telling me, or right? Are we telling ourselves that we're going to add up a half of a pizza plus a 1/4 of a pizza and get less than a half? That's a third. That's not even a half, right? No way, right? So just remember that this is not, this is not equal to. You can't just do this formula. That's not going to work. So this is the formula we want to stick to. Okay, that's a beautiful, important formula for adding fractions. Okay. And subtracting, of course. If you do a minus right there, then you would have a minus right there, plus or minus. Okay. All right. Thank you for watching. Have a great day.